Hi, everyone. This is Sebastian Traeger. I am the Managing Director of Reliability Center, and we are back with another edition of Reliability 4.0. So as always, we are on a mission to help make the world a more reliable place. And today we are excited to welcome Sujay Soman. Sujay serves as a senior reliability engineer with Samsung Austin Semiconductor. We'll learn a little bit more about him and about the company, and then hopefully we will learn a lot about what he is doing and how that can inform and encourage the rest of us in our roles. So Sujay, let me start just by welcoming you. Thank you so much for being on the show with us today.
Thank you, Sebastian. I'm happy to be on the podcast and share some of the insight I've gained in the last 11 years of my career.
Well, great. Well, just as background, I'd love for us to learn a little bit more about you. So why don't you start by just telling us a little bit more about the company you work for and your role there and how you came to be there?
Sure. So I'm a maintenance and reliability professional with 11 years of experience. I have a bachelor's in mechanical engineering and a master's in engineering management. And during my career, I've implemented robust reliability and maintenance programs for both rotating equipment and fixed equipment in the food processing and now the semiconductor industry. And I've conducted countless FMEAs, failure modes and effects analysis, RCAs, root cause analysis, while gaining industry standard certifications in vibration, lubrication, ultrasound NDT, root cause analysis training, as well as risk-based asset management. So currently I'm at Samsung Austin Semiconductor, as you stated. I'm the senior facilities reliability engineer there, where I develop the maintenance and reliability programs for our fab utility distribution systems. So these include gases, chemicals, water, vacuum, drains and exhaust, as well as some building operation systems like comfort air, HVAC. We've got elevators, roof systems. We've got loading docks and irrigation systems.
Okay. Well, so you have a lot under you there, a lot that you are in charge of for sure.
Yeah, it's good to have, experience across, diverse pieces of equipment, because they're, so unique, and, every piece of equipment, has different concepts that you can learn.
Well, good. Well, let's. I want to dive more, obviously, into your work and your career. But before we do that, just a couple things for us to get to know you a little bit better. Tell us about your family, if you have one. Just to kind of share that.
Sure. So a little bit about me and my family. So me personally, outside of work, I'm a big automotive enthusiast.
Okay.
I love working on cars and motorcycles. I do the maintenance on them. I like to improve, the components on them. In fact, learning about the different mechanical systems is what got me into engineering.
Okay.
And as far as my family, we immigrated to the United States back in 2005 from Mumbai, India. We first landed into Baltimore, Maryland. And so I completed my bachelor's in mechanical engineering at University of Maryland, Baltimore County.
Okay.
And since graduating, I've moved to Savannah, Georgia for my first career job. And now I find myself in Austin, Texas for my current role. Although my family is still remained in Maryland, so we, try and, visit each other, at least once a year.
Great. Well, how often do you get back to Mumbai?
It has been a while. The last time I visited was 2018.
Okay. Well, yeah, Mumbai is one of the more, it's one of my favorite places I've ever visited. I've actually been there a couple of times. It is an amazing city, and yeah, just incredible. For those of you all listening, just one thing, and I'm sure you can mention more interesting things. One thing I thought was fascinating is the most expensive private house in the world, which is basically a 20-story building, is there in Mumbai. But again, I know that's probably not what you all want to be famous for per se, but it's such a neat city there.
It sure is, yeah. And I hope to visit, soon. The big challenge is me personally. It's the the flight time is incredible. It's like 18-20 hours just
Right.
flight time. But once you get over that, you get to see family, friends, and you reconnect. So it
Yeah.
does make it worthwhile.
And it's just a fun, vibrant city as well. Well, let's turn our attention. We could probably talk about
Sure.
Mumbai for a lot longer, but let's turn our attention to reliability engineering. You mentioned studying in Mumbai. What's your kind of origin story? Why did you get into reliability engineering? I know that in the industry there is sort of a desire to see more people move into the field. So how did you decide to choose it yourself?
Like I mentioned, it stemmed from my personal hobbies. I was always mechanically inclined, and like I mentioned, I love working on cars, motorcycles. I like studying, the different systems and improving component reliability. So that kind of what ignited my
Yeah.
interest in mechanical engineering, and I was fortunate to find a career path that just which is in line with my
Your
hobbies.
interest. Yeah.
Yeah, and that's very rare for that to happen. A lot of times, people get into their career and it's not quite what they enjoy outside of work. And
Right.
fortunately for me, reliability is always something I've enjoyed, and and I've been fortunate to just you know
Do
be
what
in
you
the same
enjoy.
career. Yeah.
Well, that's a great message for anyone out there. Just try to if you have a hobby and you can figure out how that kind of those natural interests and proclivities connect to a market opportunity, that's certainly a great way to find a life's work. I know I've got some kids beginning their careers soon, and so I try to encourage them in that. Well, let's talk a little bit. I want to start at kind of as you think about reliability engineering and your role specifically. I want to start kind of at the biggest picture and talk a little bit about kind of the KPIs and the goals that you have. What are the KPIs that you operate under? How do you kind of think at the very highest level what it is that you're trying to accomplish?
So from a maintenance standpoint, the KPIs that are important to me personally are, labor hours spent on reactive maintenance, labor hours spent on preventive maintenance. You have maintenance cost as far as MRO inventory and major repair and replacement costs. And what make these good KPIs to me is they're easily quantifiable and
Hmm.
trackable. If your CMMS is implemented correctly. So those would be the main KPIs that are important for me in my role.
That's great. So you're saying you've made sure to connect your KPIs to your CMMS so that it's automatically feeding into those KPIs that you're solving for.
Correct. And the most to me the most important thing about KPIs is are they easily quantifiable and trackable. And like I mentioned, if your CMMS is set up right, the labor hours, the material cost, the major replacement cost, all that information can be extracted quite
And then
easily.
that must make it easy if you're ever making a business case for new tools or technologies, because you're kind of pulling the data that you're already tracking through the for KPIs. You can use those to maybe think about technology or other tools that you need.
Correct. So right now, my top priority is to improve our maintenance practice through
Okay.
implementing some innovative technologies. And so my biggest challenge right now is just making the business case, because even though an organization might be profitable, there's always, headcount and budget constraints. You're always competing with, other business units within the organization.
Right.
Um, so what I'm finding is I'm writing a lot of business cases, which early in my career as a reliability engineer, I did not expect spending this much time and energy on.
Okay. Interesting. So you've found that as you've kind of grown in your career, it's not so much more of that engineering, but making the business case. So what's the do you have a particular framework you use for developing a business case? Anything you can share with folks who maybe are yeah, just kind of struggling to make a case to somebody? How do you think that through?
Sure. I mean, the big component of business case is return on investment. And your ROI calculations need not be overcomplicated. There are many simple ROI calculations one can use that are very effective. A lot of times people, they get, the ROI calculations are, they stress out because they're not sure, what's the best way to demonstrate that ROI. But my message is, there's simple calculations out there that can be used that'll like convey the need and urgency of your project.
Okay. Is there just even getting into the nitty gritty a little bit? What are some of those components to kind of building that business case that you might say, let's just try to start with making it simple. What's kind of the most simple way you would say, here's some data that you can gather pretty quickly to make just a very basic business case, let's say?
So a simple ROI calculation. So like I said, I'm trying to implement some maintenance technology. So my ROI calculation would be something really simple, like maintenance cost savings, minus the cost of the maintenance technology implementation over the cost of the maintenance technology implementation expressed as a percentage. And the maintenance cost savings comes from the KPIs. We earlier discussed. The cost
Yeah,
savings
that's
comes
great.
from the labor hours spent on reactive maintenance, the labor hours spent on preventive maintenance, the material costs, the major repair and replacement costs. So they all kind of tie in, if your systems are set up right.
That's great. So just to summarize that, maintenance cost savings minus cost of implementing those savings. So X minus Y over, really, I think you're saying over Y. So it's kind of like take what you're trying to save, subtract out the cost of saving it, divide by the cost, and there it is, a simple ROI calculation. That's great. And then of course you can always make that presumably more and more complicated, add more variables, model it over time, et cetera. But at a very fundamental level, that's the formula right there, to make a kind of at least the beginnings of a business case. That's really helpful. You mentioned really focusing on innovation right now. Can you share what are some of those things in your priorities? What are some of those innovations that you're really focused on right now?
So these innovations are, online and digital based. We're assessing, cloud-based CMMS, with the focus on condition monitoring. An operation as large as ours, we have several thousand equipment assets, and each asset has multiple monitoring points. And as you can imagine, we have, tens and thousands of, analysis points. So we're just currently exploring how to leverage, cloud-based AI and machine learning to do all this analysis. Because traditionally, you would have, a team of analysts. You would have to train them, ensure they have the right certifications. But as the data set grows, it's slowly getting not so feasible to have a team to analyze these just the large amounts of data. So I think that the whole cloud-based CMMS, I think this is going to be the standard in 5 to 10 years. I know a lot of companies are already implementing that, so we're just in early exploration stages, if you will.
That's great. Well, and that's where because you're going to be migrating to that system or in some way, right? If it's going to be cloud based, there's a lot of moving parts there as well. to
Indeed.
think about how that goes. And so then as you're kind of moving digital, what are some of the tools you've seen out there that you would recommend to folks? Maybe you haven't started implementing them yet. That's okay. But tools that you've seen in the world of innovation that maybe excite you or are interesting. You just mentioned, of course, kind of cloud-based CMMSs. Are there others out there that you've seen?
I think from a sensor standpoint, uh, on the Internet of Things side of things, there's again you have monitoring locations out in the field, and you have to rely on a technician to go collect that
Mm-hmm.
sensor information. But if you implement some innovative sensor technology, that can be pulled in from the field. So those are some of the technologies that I'm intrigued by. It's unfortunate the traditional roles of a vibration technician, someone who collects the information, and the analysts, it's going to require some transition. Maybe we
Right.
train them to understand these cloud-based systems.
Right.
With automation, there's always going to be some transition of traditional jobs. There's definitely
Absolutely.
some consequences of that. But on the other side, say a piece of equipment is not accessible, if it's a fan motor up on a cooling tower, then you are forced to um, use some sort of remote um, sensor monitoring and analysis.
Right. That's great. Well, before we wrap up, I just want to give you an opportunity. Is there kind of one thing that you've learned, maybe expertise you've gained that you think would be helpful for other reliability engineers to hear? So I think of, just kind of that one nugget of advice or maybe a lesson learned that if you kind of could go back, here's something you wish you implemented earlier. Just again, I don't want to presuppose what I know that is, but we'd love you to just share kind of one last idea, expertise of yours with others.
Sure. So in my experience, there's a lot of debates on, what's the best way of doing, reliability, and I'm always one to back, proactive um, uh, strategies. And there's a lot of disagreements. One thing that almost no one agrees with me in the field is, just thoughtful maintenance expenditure during the design phase to ensure, equipment reliability, availability, and maintainability, whether that be installing better access to equipment, purchasing more reliable components. In my experience, project engineers will, procure, the cheapest possible components to avoid overspends, without consulting the maintenance and reliability engineers. And I understand these take some financial resources up front, and many companies, tend to value engineer, these design for reliability concepts out, but they later end up spending significant resources anyways on, maintenance, repairs, during the asset life cycle anyway. So I guess my my nugget would be to encourage, the maintenance and reliability engineers to, be involved during the design phase, and, collaborate with the design engineers, and, provide the reliability data, provide your data from the FMEA to inform, these commissioning decisions. And, I would encourage the organization to, get the maintenance and reliability engineers involved during the commissioning stage. A lot of times they get, they're pulled into the picture very late when the equipment is installed, and, here are the, the commissioning plans. But I think, the maintenance and reliability engineers should be involved during the design stage.
That's great. Well, it's, this is an analogous field, so it's not the same. I was talking to a friend yesterday who is a software engineer. So again, not exactly the same, but building software. And he has just spent the last 3 months thinking through and designing the feature that his team is going to build. And again, analogous to what you're talking about, you could argue that's time that could have been spent writing code or building the software, but their company recognizes the value of, we need to design this thing correctly. And I think that's what you're saying. If we're going to have good reliability outcomes on the back end, we need to think on the front end about how to do that.
Exactly.
That's great. Well, listen, Sujay, it has been great having you. Just really appreciate the conversation. I think what you've shared is going to be really helpful with folks, especially around thinking through an ROI in a business case. I think it was really helpful. So thanks for sharing that. Also, just great to hear a lot of your origin story and sort of lessons learned. So again, we are really thankful. This was, again, Sujay Soman, Senior Reliability Engineer at Samsung Austin Semiconductor. We appreciate you being on with us today.
Excellent. Thank you for the opportunity, and thank you for the time, to listen to me and, hear some of the insights.
Absolutely. Well, and to all those listening, again, we are here to help folks like you, reliability engineers, and anyone else, just learn how to use technology in what you're doing, how to kind of manage this transition, how you can take advantage of tools. And we just want to help you do that. So thank you for listening. Again, our company is Reliability Center. If you're looking for anything related to RCA training or consulting or software, we have a software platform called Easy RCA. We'd love to talk to you about that. And again, thanks everybody for joining us. Let's go forth now and make the world a more reliable place. We'll see you next episode.